Welcome back, everyone. Today we'll be learning the basics of algebra. First, let's look at the difference between an algebraic expression and an algebraic equation. An algebraic expression is made up of variables and constants along with algebraic operations. An algebraic equation is a mathematical statement in which two expressions are set to equal to each other. So the major difference between the algebraic expression and the algebraic equation is that the equation has an equal sign, but the expression doesn't. So for example, 2a plus 3b is an expression, but 2a plus 3b equals 20 is an equation. Now, are you ready to learn the parts of the algebraic expression or the equation? First, let us look at variables. So a variable is a letter that stands for a particular value. The variable is the unknown. In this example, the letters that are representing values are x and y. So x and y are the variables. A coefficient is a number used to multiply a variable. So as we see here, 2 is multiplying x and 4 is multiplying y. 2 and 4 are coefficients because they're multiplying or variables. Next, we have a constant. A constant is a number that stands alone. We can see 9 to the right standing all by itself. 9 is representing our constant. A term is a single expression or a number multiplied by a letter. So terms, they're separated by mathematical symbols. So the terms in this example are 2x, 4y, and 9. Now, let's learn how to simplify algebraic expressions. When simplifying algebraic expressions, we first have to identify like terms. We can subtract and add like terms together. So some key points to remember is that like terms, they're terms that contain the same variables raised to the same power. The size of the coefficient does not matter. So these are some examples of like terms and unlike terms. Let's look at our first example of simplifying expressions. So remember, like terms are terms with the same variables raised to the same power. So by looking at this algebraic expression, can we identify any like terms? The variable for this term is y. The variable for this term is a. And the variable for this term is y. So we know that 2y and 4y are like terms because they have the same variables. So now we can group like terms together. So we have 2y plus 4y. So these two are like terms, plus 3a. Now we can only add like terms with each other. We can only subtract like terms from each other. We can only group like terms. Unlike terms stay by themselves. Now let's add the like terms. So 2y plus 4y gives us 6y. This is just like saying 2 apples plus 4 apples equals 6 apples, right? 2 bananas plus 4 bananas equals 6 bananas. So 2y plus 4y equals 6y. Then we have 3a, and we don't have anything to group 3a with, so we just have plus 3a. So to simplify this algebraic expression, we would end up with 6y plus 3a. Let's look at another example. So the first thing that we have to do is identify the like terms so that we can group them together. And remember, like terms have the same variables raised to the same power. So we can see that the variable for this term is a, and the variable for this term is a. So these two are like terms. So let's group them. So that's 5a minus a. The variable for this term is b, and the variable for this term is b. So 4b and 3b are like terms. So that's plus 4b plus 3b. Now we can subtract and add the like terms together in order to simplify the expression. So here we have 5a minus a. When we have a variable standing by itself without a visible coefficient, we know that the coefficient is 1. So this is 5a minus 1a, which is going to give us 4a. It's just like saying 5 apples minus 1 apple. Then we have 4b plus 3b. And 4 bananas plus 3 bananas is going to give us 7 bananas. To simplify this expression, would end up with 4a plus 7b. Let's look at this example. So we first have to identify like terms so that we can group them together. And remember, for it to be considered a like term, they must have the same variable raised to the same power. For all of these terms, we can clearly see that the variable is y. But are they raised to the same power in every term? No, because we see where y is raised to the second power. So we know that this term is unlike the other terms. So 4y minus 3y are like terms. Then we have plus 2y squared. So even though the variables are y for all the terms, they were not all raised to the same power. So we could not consider the 2y squared like the 3y and the 4y. Remember when we did the laws of indices and we said whenever we see a base without a visible power, we know it's raised to the power of 1. So 4y is raised to the power of 1. And in 3y, y is also raised to the power of 1. So those are like terms and 2y squared is unlike. So now we can go ahead and subtract. Now we have 4y minus 3y, which equals 1y, which can just be written as y. And on this side, we have plus 2y squared. So when we simplify this algebraic expression, we end up with this expression.